Hello guys, in this video I will show you how to solve reverse k-element sublist. This one is in category of in place reversal linked list pattern. So given the head of a linked list and a number k, reverse every k size sublist starting from the head. If in the end you are left with a sublist with less than k elements, reverse it too, right? So given this this linked list 1 to 8, right? So there's total of 8 nodes and k is 3. So what is the output here? For the output we have to reverse every k size sublist, right? So there's total of 3 sublists of size 3, right? Size k, which is 3. The first sublist is 1, 2, 3. Second is 4, 5, 6. The last one is 7, 8, right? So the first one, I'm gonna reverse it, right? So 3 point by 2 point by 3, right? So this is the first sublist. We reverse, right? Reverse the second sublist. 4.2, sorry, pointed by 5, pointed by 6, right? The last sublist 7, pointed by 8, right? So after reverse the sublist, we're gonna connect them together. So 3 will be the head of new sublist, right? 3.2, 2.2. It's the same here, but it's just a different way, right? Here is the same, right? As you can see, 3.2, 3.1. I just put 3 to the head, right? So the next node of 1 is not 4, but the 6, right? 0.6, 0.25, 0.24, and the next node of 4 is a new head of this sublist. New head is 8, right? So 0.28, 0.27, and 7 is the last node, so it's 0.0. Okay, so here is our output, right? So I've tried to break it down into multiple steps, but at the end what you need to return is this one, right? So as we've gone through the explanation, I've break it down into sublet of cycles, reverse each of them, then connect them together. So that is exactly what we're gonna do to actually solve this problem, okay? So for this one, what we're gonna do here is, of course, we're we need to reverse to iterate to for every node, right? So we must somehow mark the sublist as we iterate into elements to every node, and we must come up a way to separate the sublist, right? And so that we can keep track of the new head of the sublist, right? And the new tail node of the sublist of the previous sublist, and the new head of the current sublist, right? So the idea here is to, we need to keep track of as we go through. We must have a way to mark the sublist, right? As we process the elements, we must have a way to group the sublist together into sublist of size k. We also need to remember the end of the previous sublist, right? So there's a couple of things here. We must group nodes into sublists of size k, right? We need to remember the new tail. For this case, 1 is the new tail of the previous sublist, right? For considering that we are possessing this sublist, then 1 is the new tail of previous sublist. And we need to know the new head. The new head. Must to remember new head. New head. Okay, new head of current sublist. Okay, here is I think pretty much some bullet points, the main things that we need to consider, right? So we need to iterate every node, right? So how to iterate through every node? We need to probably first we need a working pointer, right? We need a working pointer, which is current. Let's say initially is head node, right? So as long as the current is not null, then we keep iterating, right? We need to, okay. So we need to group nodes into sublist of size k, right? So in order to do so, I'm gonna use another loop in here, right? The loop here. This loop will process current sublist, right, of size k. Process current sublist of size k. Okay. So in order to process the current sublist size k, how I can do it here is to probably check when I use a variable, a counter variable, which is I equal to 0, right? So as long as I is still less than the k, wanna process continue iterate, continue to iterate, right? So process this sublist. Process here is actually to reverse this sublist, right? To reverse this sublist. So it's the same here. We try to reverse every sublist. So the logic of reverse sublist is the same as two previous problems. So in order to reverse, we need two variables, the current and previous, right? So here we have current already, right? So the previous initially is null, right? So we start reverse current sublist of size k, right? Okay. How to reverse it? So at each node, right? At current node, our goal is to point the next pointer of current node to its previous, right? But by doing that, we accidentally lose the connection to its current next, right? So we probably want to set the current next before doing something, before modifying the next pointer, current next, right? So okay, we save current next, and now we point current next to its previous, the previous node, right? So so before moving current to current next, we probably want to reassign the previous node, right? So here processing before next iteration, right? We must reassign the previous node. Previous is current, right? Previous is reassigned as current, and then we can we can make current the next node, right? We move our pointer forward, the working pointer forward for the next node to be processed. The current is equal to current next which is what we have saved here, right? So also we need to increment the I, right? So here we've done with the logic of iterating every node. We done grouping nodes into certain cycle, okay, and reverse. Okay. There are two things left here, which is remember the new tail of previous. Another thing is to connect sublist, right? Remember the new tail of previous sublist. So as we processing, right, we want to remember the new tail of previous sublist. For the first sublist, for example, here we have no tail previous sublist, right? So it initially is tail of previous sublist. Okay, is null, right? Okay, so where we can reassign this one. So as you can see, so the new tail of previous sublist is actually let's say new tail of previous sublist, new head of current sublist. New head of current sublist is actually, for example, we are here, new head of sublist is sick, right? So after we exit this inner loop, we are then here I is equal to k, right? It means we are here, the current is here, right? We done reversing the sublist and current is here, the previous is here. So it means it means here is the sick is the head of current sublist, right? But what we need here is the foreign state, right? So so that no, sorry, wait a minute. Exactly, the previous is the new head of current sublist. Previous now is new head of current sublist. So we are this one, new head of current sublist, right? So the new tail of previous sublist, we need to new tail of previous sublist. Its initially is no. So here we can point the tail, point next, right? Next tail of previous sublist. We point to head of current sublist. New head of current sublist is previous breath here. Okay. But we must find a way to. Oh, there's two cases here. The tail of previous sublist initially is no. So for the first sublist, let's say it will be no, right? So if tail is not no, then we're gonna connect the previous sublist with the current sublist by this line, right? But if, but else, in case tail previous sublist is no, it means we are at the first sublist. In this case, in this case, it means we just want to reassign the new head of the linked list, right? So for the first iterations, for the first sublist, after we existing here, it means we're at 4, right? And 3 is breadth, right? 3 is breadth, 4 is curve, and 3 will be the new head of the whole sublist. Okay, so it means head will now breadth. Okay, but there's one more thing, which is tail current sublist. Okay, we must have a way to tail previous sublist. This guy. So if we are this sublist, so we done reversing it, right? So we want to point the tail of previous sublist to here. But now after we moving to this new sublist, right? Before moving to the new sublist, we must update our tail of previous sublist, right? So that as we are here, as we are processing this sublist, we have new tail of previous sublist is 4, but not 1, right? Let me see. Okay, update. Tail of previous sublist. So tail before moving to the next. Okay. Tail of previous sublist. it means so we are here, right? We are now at this curve is 7, perhaps is 6. We need to reassign new tail of previous to 4. It means we must save our node 4 before reversing here. So it means, let's say, how about a tail? Let's say. Let me see. Tail of current sublist is no initially, and tail of current sublist, I want to save it here. Tail of current sublist is current, right? So add with like before processing any sublist, mean we are at 1, we are at 1, or we are at 4, we are at 7, right? Here you want to save the current head, but later will become the new tail. So we will save it here to current, right? Okay, we reverse the sublist. Okay, we point tail of previous sublist if there is, if it exists, right? Then we update tail of previous sublist to previous sublist. Tail of previous sublist is now tail of current sublist, right? So I think so we are for this sublist. We are at 1. We set tail of current sublist is 1, right? The new tail of current sublist is 1, right? So we reverse it. And before moving to the next sublist, wanna reassign tail previous sublist to tail current sublist. So as we are here, the tail previous sublist is the one here. So that's it. That is it. I think I'm gonna return head. Okay, let's say just 6 3. Okay, let's see what we have here. Oops, come on, man. Okay, we oops, current next is curve dot next. let me see. We set dot next. Okay, go dot next. Point next is previous. Okay, reassign previous to. Okay, move the booking pointer to the next one, which is what we save here. Increase by 1 so that we process reverse exactly keynotes. But what is wrong here? What is wrong here? Previous instruction, no. Tail of concept, okay. Before, okay. I'm not sure what's wrong here. So let's debug it. Okay. Let's say previous no. Previous to okay. One, two, three, four, five, six. Okay, it's the same as this example. Let's copy it over slide. Easy. Okay. Let's move it here. Okay. Code.val prep okay. Current initially is 1. Right. Okay. Till previous sublist, okay, is initially here's a new tail of current sublist, right? So after processing reverse this sublist, it will be the new tail, right? That's not I. Okay. Go to next. We save the next pointer. Okay. We point next occur to this previous, which is no initially. Let's remove this. Prep is now no. Okay. Previous equal to processing before the next iteration. Previous will reassign the previous. Okay. Then we move the next, which is 2 now. Okay. I increase by 1. Okay. So now 2 is next. 2 is pointing to 1. Right. Next. No, sorry. Now 1 is pointing no. Current is 2. Right. Okay. connects E3. Okay. We point curve to previous, which is 1. Okay. It seems correct here. Previous is now 2. Curve connects is 3, right? I plus 1. Now I is still okay. Next, last iterations. Curve is 4. We exit here. I is E3. No longer less than 3. So we exit here. Current is here. Pref is here. So do we have a tail of previous sublist? No, we don't have. So we move here. The head of new head of host list is now 3. Okay. Update the tail of previous sublist. So before jumping into this sublist, on the reassign the tail of previous sublist to 1. Hopefully it will. Okay. Tail of previous sublist is 1 now, right? So tail of current sublist now is 4. Oh, it seems correct. Again. Oh, I know why. Probably for the last sublist, which is here, we need to point this one to no, right? We forgot to do. So everything here is correct, but we forgot one thing only. So we exit when previous is when pref here is 8, right? And the 7 is actually tail of current sublist. So tail of current sublist. Next is no. It takes a lot of time to figure it out. Oh, come on. What's wrong here? I know why. In the last iterations, we have only 2 nodes here. So here we runs we don't stop when current is null, right? So we only want to jumping in here when the current is not null. And I see. Okay. Okay. Let's run it again. Okay, it works. So it's been a long video. So thanks for watching. See you in the next one. Bye.